I'm astronomer Doug Duncan of the Fisk Planetarium at the University of Colorado Boulder. Welcome to Explorations, the series that takes a look into NASA's diverse projects and the people who make them happen. After decades of exploring, humans have sent a spacecraft flying past every major object in our solar system, except for one, the Sun. Hundreds of engineers, scientists, and technicians spent nearly a decade constructing the Parker Solar Probe for an ambitious goal to become the first human-made object to enter the Sun's atmosphere. In August 2018, NASA successfully launched the Parker Solar Probe from Cape Canaveral. The probe has survived its first dip into the Sun's corona, the outermost layer of the Sun's atmosphere, where the probe endured temperatures hotter than flowing lava. The Sun is 93 million miles from the Earth. To conserve fuel for this long trip, Parker Solar Probe is using 7 slingshots around Venus to control its trajectory. At its closest approach, Parker Solar Probe will be 6 times closer to the Sun than the planet Mercury, speeding by at 120 miles per second. Due to its highly elliptical orbit, when the probe is farther from the Sun, it slows down. But at its point of closest approach, it accelerates to 430,000 miles an hour. So fast that if it was orbiting the Earth, it could do so in 3.5 minutes. Parker Solar Probe is the fastest object humans have ever built. Why would scientists want to send a spacecraft into such an inhospitable environment? And what can we learn there? We've asked Gilly, a graduate student at the University of Colorado Boulder who's studying the Sun, what makes the corona so enticing?
Hi, my name's Gilly, and I'm a PhD student at the University of Colorado where I study the Sun. Right now I'm sitting in front of a heliostat, which is one of the earliest instruments that we use to study the Sun. But now we have the Parker Solar Probe, which can actually go to the Sun to measure the corona. So why study the corona? Well, there's lots of reasons, but I'm most interested in the solar wind. The solar wind is a gas that's expanding out from the Sun in all directions, and it fills the entire solar system. You know, a lot of people think that the solar system is mostly empty, but actually the solar wind is strong enough that it's able to strip the entire atmosphere off of Mars. And we really don't understand how that solar wind is accelerated, the ways that it comes off of the Sun. And the only way to figure that out is to go there and measure it. Why? Well, there's a lot of things that you can't measure from a distance. It's sort of like if you can imagine a sandwich across a room. You don't know if it's a tasty sandwich unless you actually go over there and take a bite. Parker Solar Probe is going to go to the Sun and taste the corona. What's really interesting to me about this field is that the Sun is right there in our solar system. I love studying space, but I love that in my field I get to study space that affects the Earth. This is our home, and the Parker Solar Probe is going to answer questions about our solar system.
The corona is composed of extremely energetic particles, and you can see it with your naked eye as the beautiful, tenuous, silver streamers during a total eclipse. If conditions are right, these particles get flung off into space as the solar wind. The instruments on the Parker Solar Probe will allow us to better understand how and why this happens. These instruments will measure the number of particles, what type they are, and their properties like speed and electrical charge. The instruments will also measure the electric and magnetic fields that the particles are embedded in. It's these fields that power the solar wind. Parker Solar Probe also has a camera to study the patterns in the corona, helping us better understand how the energy flows through it. These instruments need to be shielded from the hot radiation from the sun, which will be over 400 times as intense as you would feel in the desert of Death Valley. NASA engineers designed a coolant system and a 4.5-inch thick carbon composite heat shield to protect the delicate instruments. At closest approach, the probe's shield will reach temperatures of about 2,500 degrees Fahrenheit, while the shadowed instruments remain near room temperature. As the Parker Solar Probe dives into this sea of solar energy, it will help us unfold the mysteries of the largest object in our solar system. The solar wind has profound effects on our satellites, our phones, our electrical grids. But how is it created? This mission has the potential to answer this question and many more, prompting new questions for future generations to investigate. On behalf of NASA and Fisk Planetarium at the University of Colorado Boulder, thank you for joining us for this episode of Explorations.